This is General Chemistry 2, and this afternoon, we will be talking about thermodynamics. Okay, so part 1. So, energy and heat, yung ating pag-uusapan. So, what is energy? Ano ba yung energy? Okay, we often say na kailangan ko ng energy, nanghihina ako. Okay, so in that context, that's another kind of energy. Okay, now basically, energy is that property that something has which enables it to do work. Okay, yan, enables it to do work. So basically, energy is required, okay, to do something like work. Okay, now, speaking of energy, there are actually three general categories. So, tatlo yon. Okay, general lang naman ito. Pero, it's not as simple as that. Kasi pag pinag-usapan natin energy class, napakalawak na topic nito. But we start with the basics. First, it would be kinetic energy. Okay, so I'm giving you here the very, very simple or the simplest description of these three categories of energy. So starting with kinetic energy, it is the energy a body has by virtue of its motion. Okay? Kaya kinetic energy yan. Kaya nga ngayon, di ba, other sources of energy kasi na medyo nauubos na yung ating tawag dito yung ating ano ba tawag doon? Yung fuel natin na fossil-based, nauubos na. So there are other sources are being explored and one of them is kinetic energy. Okay? Yan. So ginagamit yung mga very, very fast-moving particles like the electrons. Okay? Now the other one is potential energy. Now this one naman is the energy a body has by virtue of its position. Okay? So position naman yan. Alright? And like for example, yung dam, 'di ba, may potential siya. Kasi nandun siya kaya nakaano siya sa taas, 'di ba? And then when the water is flowing, that potential is converted into something like kinetic energy, okay? And then we have rest energy. This is the energy a body has by virtue of its mass alone. Okay? So ito naman yung concept that matter can exist as a particle and as a energy. Yan. So by virtue of mass. Yan. So even as an atom, meron siyang energy. Okay? Yan. All right? So with that, let's start with kinetic molecular theory because the succeeding tone ng ating pag-uusap ng energy, heat and energy, okay? Specifically heat has something to do with kinetic molecular theory. So review natin to, na-discuss natin to last time, but let us review this. So sabi ng kinetic molecular theory, matter is made up of particles that are constantly moving. Okay? So always moving and constantly in any direction. Mamaya papakita ko sa inyo the different and constantly and randomly. Okay? Random talaga. Okay? So all particles have energy, but the energy varies depending on the temperature of the sample of matter. Okay? The temperature the sample of matter is in. This in turn determines whether the substance exists in the solid, liquid, or gaseous state. Okay? Molecules in the solid phase have the least amount of energy, while gas particles have the greatest amount of energy. Diba last time, when we talked about intermolecular forces, nakita natin ito, di ba? Or why is it that the gas particles are constantly moving? Okay, because the particles are arranged so far apart from each other, and so it is easy for them to move. Okay? Kaya mas great ang kanilang motion. Okay? So, there's something to do with. Kaya nga yung solids, yan yung least ng energy because the particles of solids are so confined, para bang restricted ang movement nila. Okay? And then, the temperature of a substance is a measure of the average kinetic energy of the particles. Okay? So, yung na-measure natin na temperature, average kinetic energy yon ng bawat particle. Okay? So, kung million-million yung particle, million different kinetic energies kasi per molecule yun di ba yung kinetic energy? And then if you get the average velocity of all of this, that would be the temperature. Okay? So, a change in phase may occur when the energy of the particle is changed. O, di ba? Kaya nga sa water, very evident yan sa water, di ba? As liquid, as you increase the temperature, okay, the bonds between the liquid molecules would break and they would be changed into water vapor, di ba? Now, sa liquid water naman, if you decrease, okay, the temperature, okay, they would change. So, parang you compress the molecules, okay, they would be compressed, so nagiging solid. So, yan yung phase change. Okay? So, I hope we will be able to discuss that. Sana abutan natin, okay? All right. Then, there are spaces between particles of matter. The average amount of empty space between the molecules gets progressively larger as sample of matter moves from the solid to the liquid and to the gas phases. O, ayan. So, yung spaces sa solid, sobrang dikit-dikit kasi, kaya halos maliliit lang yung spaces. Sa liquid naman, okay, o medyo loose, okay? Pero sa gas phase, mas significant yung kinetic energy kaysa yung space between them kasi halos parang wala nang parang negligible na yung bonds between the molecules. That is the reason why they can move anywhere and in any direction, okay? Now, there are attractive forces. Okay? Ayan. I think we have discussed this the last time dun sa ating intermolecular forces. So, there are attractive forces between atoms and molecules or molecules, and this becomes stronger as the particles move closer together. Okay? So, ito yung mga tinatawag natin attractive forces which are called intermolecular forces. Okay? So, sa gases kasi, mas significant yung tawag dito yung motion nila kesa dun sa kanilang forces. Okay? Yan. Kasi nga, they are so far apart. Halos negligible. Okay? And it's this tawag dito, very weak intermolecular forces that make the gas particles very fast moving, very talaga mabilis, okay? And in fact, they could skate. Okay? So that's why they skate. Okay? Ayan. Alright? So that's about kinetic molecular theory. Okay, sabi ko kanina, the particles are constantly moving and in random motion, okay, in any direction. So these are the different random motion of molecules. So we have translational. So pag sinabi na natin translational, it moves from one position to another. Okay, pag rotational naman, you know what rotation is, di ba? Umiikot-ikot. And then vibrational, nagva-vibrate. Okay, so to imagine that, ito yon. Okay, so pag translational, it moves from this position to that position. Diba? Pag rotational naman, umiikot-ikot siyang ganun, diba? Pag vibrational, it is seen in the bands. Okay, now this picture here is an illustration of a water molecule. Okay, so this is the oxygen and these two are the hydrogen atoms and banded together. Okay? So, yung nagba-vibrate, yung sa band, na parang nag-i-stretch na ganon, or yung dalawa ganon. Yun yung vibration na nangyayari. Now, all of this are happening all at the same time. Okay? O kaya lang, ang mas nangingibabaw dyan halos ay translational motion. Okay? And maybe next to that would be rotational. Okay? So, hindi, as compared to translational, mas maunti lang yung rotational and vibrational. But all of them are all happening at the same time. Okay? Minsan siguro mas lamang yung rotational. O, depende kasi kung medyo masyadong close together yung molecules o na hindi makapag-translate, change ng position, probably rotational and vibrational ang nangyayari. Okay, so depende, di ba? Okay, but for the gases, you can guess na translational ang mas lamang o kasi there's so wide space between the molecules so that they can really move from one position to another. Okay, so these are the different random motion of molecules and even atoms. Okay, all right. So internal energy, ayan. Kanina, pinag-usapan natin kinetic energy. Okay? So the internal energy is the kinetic energies of the atoms or molecules of matter. Okay? So whether they are solid, liquid, or gas that are in constant random motion. Okay, so kung lahat ng molecules of matter, whether solid, liquid, or gas, are in constant motion, okay, they are producing kinetic energy. At yun yung tinatawag nating internal energy. Okay? Ayan. So, the average kinetic energy of these particles is measured as temperature. Ayan. Kaya dun sa kinetic theory natin kanina, it mentioned about temperature. Okay? Now, heat is a form of energy caused by the internal motion of atoms and molecules of matter. Okay? Kaya nga, di ba, we measure heat by using, we get, parang one way of measuring heat is by its temperature, di ba? Pag nilalag na to, ang init mo di ba? You are getting heat, di ba? O, heat ang pinag-uusapan doon. Okay? Now, heat, speaking of heat, we call it internal energy in transit. Why is it called internal energy in transit? Ano ibig sabihin pag in transit? Ibig sabihin transient. Ibig sabihin, pwede siya magpalipat-lipat. Yun ang ibig sabihin ng transit. Okay? Kaya nga, transient. Okay, so when heat is added to a body, its internal energy increases and its temperature rises. When it is removed from a body, its internal energy decreases and its temperature falls. O, di ba? So, pwede siyang idagdag, pwedeng alisin. So, depende. Okay? Yan, that is heat. Okay? So, nag-i-increase yung, ang kaibahan niyan sa internal energy is yung based on the movement, based on the kinetic energies of the particles. Yun. Okay? But, heat could be added. Okay? And it is going to increase the internal energy. Yun. Kaya nag-i-increase ang temperature. Alright? So, therefore, heat is a form of energy, okay, that when added to a body of matter, increases the internal energy content of the body. Okay? And so, the temperature is increased. Okay? And with that, let us discuss thermal equilibrium and zeroth law of thermodynamics. Okay? So, ngayon yung lang ba narinig yan? So, meron tinatawag na first law of thermodynamics, second law, merong zeroth law. Okay? And let's take a look at this. Thermal equilibrium. Okay, so, ano ba yung temperature? Temperature is often associated with the qualitative idea of hot and cold. Diba? Kunyari, there are 3 glasses of water. Okay, yung isang glass, cold water. Yung isang glass is hot water. Yung hot na pwedeng idawdaw yung daliri, hindi yung kumukulo. Okay, and then we have a third glass in the middle, itong cold and hot. Okay, tapos i-mix natin, so that the temperature would be in between. Okay? Now, if 2 people magdawdaw ng daliri dun sa cold, okay, sasabihin mo ay malamig. Tapos yung isa naman, dadawdaw niya dun sa hot, sabihin niya ay hot. Okay? Now, if both of them, yung nagdawdaw dun sa cold, pag dinawdaw niya dun sa gitna, di ba yung gitna is in between, sasabihin niya yon hot. Pero pag ang magdadawdaw dun ay yung nagdawdaw dun sa hot, sasabihin niya cold. Okay? So, it is just a qualitative idea of hot or cold. Qualitative lang. Now, temperature can give a quantitative idea of hot and cold, regardless of the individual differences in sensations of hot and cold. Okay? So, it could be measured quantitatively using thermometer. O, ayan. Kaya nga, may thermometer. It is a device that we use to measure temperature. Okay? Yung design ng thermometer is based on the concept of thermal equilibrium and the zeroth law of thermodynamics. So, ano ba yun? Ano ba yung konsepto na yan? Okay? So, let's continue. Alright, so, I'm going to use an illustration to explain that. Okay, so imagine system A and system B. Okay, now system A, may particles siya. Okay, so you go back to the kinetic theory na pinag-usapan natin kanina. So, may particles, kung mataas ang internal energy, okay, mataas yung kanyang motion. So, mabilis. Okay, mabilis yung movement ng mga particles doon. Now, sa system B naman, medyo mabagal. Okay? Ayan. Okay, so how is it transferred? Now, if the particles in system A can go to system B, okay? Yan, kasi mabilis ito, mabagal ito, so most likely dahil sa bilis niya, lulusot siya doon kay system B. Okay, so pag lumusot siya doon, dahil mabilis siya, mababangga niya yung ibang particles sa system B, bibilis ngayon. Until, okay, it reaches an equilibrium. Okay? So pag equilibrium, wala nang transfer. Okay? Ng energy. So that is, yun, it's said to be nasa equilibrium na siya. Nasa equilibrium. Okay? So another way to illustrate that is like this. Okay? So lagay natin yung system A dito, yung system B dito. Okay? And then there's a third system. Itong dalawang ito are separated by an insulator. Okay? Alright. So, magkakaiba yung motion ng particles dyan, ha? Okay, now, kaso, yung particles ni System A, nakakalusot kay System C. Ganon din si System B. Okay? So, it continues, okay? The motion continues until, okay, medyo yung maging in equilibrium na uli. Okay? Yung kanilang movement. Kumbaga, wala, parang pare-pareho na ang velocities ng kanilang mga particles. Okay? So, the system, itong una nating picture, illustrated equilibrium, but yung third, itong ikalawa nating system, also illustrated an equilibrium. But it's a picture of the Zeroth law of thermodynamics, which states that two systems that are in thermal equilibrium with a third system, okay, that should be thermal, that are in thermal equilibrium, okay, with a third system are in equilibrium or thermal equilibrium with each other. So, kamukha nung nakita natin. So, ganito, balik natin ha, ito sa dati. Here. Okay, o, di ba? Ito, sabi natin, this is, una muna, wala silang thermal equilibrium with each other, okay? But then there came a time that System A became in thermal equilibrium with System C. And likewise, System B, there came a time na naging internal equilibrium na siya with System C. So in that case, okay, both of them are in internal equilibrium with each other, okay, with each other. So, that is a picture of the Zeroth law of thermodynamics. Kaya sabi dito, two systems that are in thermal equilibrium with a third system are in thermal equilibrium with each other. Okay? Ayan. Okay, so let's go back to temperature. Okay? So ano ba yung temperature? It is a property of system that determines whether or not it is in thermal equilibrium with another system. Okay, so yan yung basis ng design ng thermometer. Okay, so it is proportional to the average kinetic energy of the atoms and molecules of an object. Okay, so two systems in thermal equilibrium with each other have the same temperature. O, di ba? Yan, have the same temperature. Kaya yung thermometers natin, these are instruments designed to take temperature measurements. O kaya nga, di ba, pag may lagnat, o papababain yung ng thermometer, di ba? Tapos ilalagay sa kilikili o sa ilalim ng dila, di ba? Pag tataas yan, kasi tumataas yung temperature mo. Okay? Ngayon, yung particles mo sa iyo, okay, will be in contact with the particles of the thermometer, di ba? Tapos, biglang titigil na ngayon yung pagtaas nung ano ba yung nasa thermometer? Mercury ba yon? O pag tumigil doon, that means the thermometer and your body are already in thermal equilibrium with each other. O, nakuha nyo? In thermal equilibrium. So, that's how thermometers were designed. Okay, so when a thermometer is in thermal equilibrium with another body, the reading gives the temperature of the other body. Yan. Okay, so ganun din design. Okay, so in designing the thermometer, it makes use of materials that really, expand with temperature. Kaya sa yung usual na thermometer natin, ang ginagamit dun ay tawag dito, mercury. Kasi 'di ba, pag nag-increase yung temperature, mag-e-expand siya. Since hindi siya maka-expand, makitid lang yung tube, tataas na lang siya. 'Di ba? Yun yung means of expansion niya. And pag tumigil siya ng pagtaas, that is already the thermometer reading, which is the temperature of your body. Okay? All right. So I hope that is clear. Okay, next, heat and temperature. Okay, ayan. Let's take a look at this. Okay, so we have, right, so let us assume that the water in the teacup and the water in the pail has the same temperature. Okay, so pareho ang temperature. Okay, ayan. Bakit kaya? Pareho eh. And then, the average kinetic energy of the water molecules in both containers is the same. That's the reason why they have the same temperature. However, when we speak of energy, yan, energy itself, syempre, the energy of the water in the pail is greater. Okay? Why? Because there are many more water molecules in the pail, so the sum of all of their kinetic energies is greater. So pag ang pinag-usapan dito is the kinetic energy per molecule, then and you get the average eh. 'Di ba? Kahit 100 lang, 'di ba? Pag kinuha mo yung average i-compare mo sa average sa kunyari 10, halos pareho lang 'yon. Pero pag ang pinag-usapan ay total energy, syempre kung saan yung mas marami yung molecules, yun ang mas greater ang energy. Okay? Is that clear? Does that make sense? Okay. So moving on, because the water in the pail has more mass, it has more energy, even if they have the same temperature. Okay? Yan yun. That's the reason for that. Alright? So that's comparing heat and temperature. Okay? Okay. So, of course, they would have the same heat kasi pareho ang temperature kasi temperature is a measure of heat. But the energy itself, the total energy ang pinag-uusapan natin. Okay? Alright. So, now, different substances respond differently to the addition or removal of heat. Okay? Different temperatures respond. Okay? So, for example, equal mass and heat. Okay, so we have two different objects na parehong equal mass. Let's say parehong 1 kilogram, okay, of water. Okay, and then we add heat na the same. Kunyari, 1 kilocalorie. Okay, now in terms of change in temperature, okay, 1 kilogram of water will increase its temperature by 1 degree when 1 kilocalorie of heat is added. Okay, what about if it is 1 kilogram of aluminum? Okay, so 1 kilogram of aluminum increases its temperature by 4.5 degrees when 1 kilocalorie of heat is added. Why is that so? Magkaiba. So, magkaiba ang response nila sa added heat. Okay? Remember, this is about, so ang ano dito is the increase in temperature. Diba? Okay. So, that one is described by, if various substances increase in temperature variably when 1 kilocalorie of heat is added to 1 kilogram of the substances, that is what we call a specific heat. Okay? Now, if we compare that to equal mass and temperature change naman, okay, so that is, equal mass and temperature. Okay? Pag equal mass and equal temperature naman, okay, ano ang magva-vary? The amount of heat. Okay? The amount of heat that would be added. Kung the same change in temperature, for example, ito, gamitin uli natin yung water and aluminum. Okay? If 1 kilogram and you increase 1 kilocalorie, 1 degree Celsius ang increase niya. Okay? Now, kung 1 kilogram ng aluminum and you add 1 kilocalorie of heat, 4.5 degrees Celsius ang increase niya. Okay? Yun yung response because these are two different substances. Right? Now, suppose it's 1 kilogram, okay? And then, we allow both, we add heat to both so that they will have the same increase in temperature. Makikita nyo na magkaiba ang amount of heat. Okay? Now, that one is what we call specific heat. Okay? Now, what is specific heat? It is the amount of heat needed to change the temperature of a unit quantity of a substance by 1 degree. Okay? Yan. Yun yung, remember doon sa isa kong, okay. Yan. Equal mass and temperature change. So, parehong mass, pareho ang increase. But, they will need different amounts of heat for that same increase in temperature. And yun yung tinatawag na specific heat. Okay? Yun yung specific heat. So that is why, okay, it is the amount of heat needed to change the temperature of a unit quantity of a substance by 1 degree. Okay? Or, in another way, kanina kasi ginamit natin ay 1 kilogram at saka 1 degree Celsius o 1 degree. Kasi pwedeng 1 degree Fahrenheit, 1 degree Rankine, or 1 degree Kelvin. Ito, general ito. Okay? O kanina doon sa example natin, it is specifically 1 kilogram and then 1 degree Celsius ang increase. Okay? So it is, specific heat can also be described as the amount of heat needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Okay? So that is specific heat. Okay? All right? Okay. So that's it.